There will be two options for the classes. Remember that we have to work with ceiling plans, level 0. We have a lot of stuff in the classroom, and I'm talking about the office now. So we don't have anything in the office. We are going to do the same system that we have in the offices in the TDS building. There is a cassette air conditioner, and this is connected to the air handling unit. So there are two options. We're going to connect this to the existing air handling unit, and the second option, we're going to connect it to a new air handling unit. So the first thing that we notice when we try to insert this is that if we insert that element, it goes directly on the slab, so that can't happen. First, we have to create a ceiling. If we go to architecture ceiling, we have to change the elevation to 10 feet, and then we can create a ceiling. See that there's a grid, so that means that we have a false ceiling there. And now we can insert the systems, the mechanical, this thing, we can insert it here. If we go to the 3D view, now we see that it's 10 feet from the floor, and it's inserted in the false ceiling. Okay. Now this is at the same time it's an indoor unit connected to the outdoor unit through these two pipes, and at the same time it's a diffuser, so this is connected to the air handling unit or to the supply duct of the air handling unit. If we right click and draw a duct, you see that it's red. Red is the same color as we have in the supply. So we have to connect this to the supply unit, and this connection it's always by means of a flex duct like this. Every time we use the flex duct, remember that Revit does something a little weird, so we have to delete, rotate, and now we can flex duct here. Okay, I didn't change the airflow. This is now that works as a supply. So remember that the supply it has the airflow. In the class it's 600. That's why we have three supply diffusers with 200 each. In the office we have 5 people times 20. It's 100. Okay, so if we have only one supply diffuser, that would be the flow would be 100. This would be 100, and if this branch is 1200, they should be 1300 if everything goes well. Yeah, so that should be 1300. Okay, so now we have to do the same thing in every single classroom. So we can copy ceiling plan level 0. I can copy everything here, and I can use the flex duct to connect it, and every time I do this I have to change the T. You might have the supply duct here. If that happens, you have to open a new branch by clicking here. So we keep going with this, draw duct, and finally we can draw the flex duct here. If everything goes well, the final airflow at the end of the first floor, it must be 600 per classroom, so 800, 1800, sorry, plus 1, 2, 3, so that would be 2100 if everything goes well. Yeah, 2100. What's next? Now we need to connect one of those to the same, or to a different outer unit. Okay, so we can connect this and that. We can do it manually, or we can have Revit decide. Revit sometimes it does a good work deciding how to connect this. So if we select both things at once, we click piping. This is hydronic. Well, it's not hydronic exactly, it's refrigerant fluid, but that's fine. And then we can generate layout, and Revit does something preposterous, okay? But we can fix it. At least we have a proposal, and then if we keep moving this, remember that we have to go to this shaft. So yeah, I'm not very happy with this, but if we keep going, yeah, that's the problem that we have here. Okay, we can fix it because this is not the right way. I don't want to go up, I want to go down actually. And I don't want to move this up, I want to move it in the other direction. Sometimes, okay, I have this pipe and I have this one here. Revit has routing solutions. Okay, anyway, let's do it by hand. Draw pipe, then we have to go down. If we go down, we have to change the elevation to negative something. So now we apply, we are down, and if everything goes well, we should connect this at the same level as that one. If we do that, does Revit do all the job? Yes, it does it, and we don't need this, and we don't need that, and then we have to turn this T into the elbow. But look at this, we have a beautiful conflict here. So what can we do? Probably we can move it in this direction, or we can move this one in the other direction until we fix that. Okay, and this is within the shaft. Okay, so it's getting more complicated. And finally, we have to connect. I think it's easier doing it by hand. So we are going to connect another, because we have two pipes here. So I'm going to connect. But once we have the first layout, the second it's easier, because we know that we have to go parallel, and then we have to go up, changing the elevation, up, not down. Throw pipe, if this elevation is 10, I'm going to go 30 and apply. And now we have to connect this one. like this. Okay, so this is one classroom. We have the split indoor unit. It's connected to the supply ductwork of the air handling unit, and then it's connected to the outdoor heat pump with two different pipes. Are we done? Well, not yet, because this is the supply. We need a return. So for the return, we need a return duct. So I can copy one of those here. I need to fix the airflow, the same airflow, it's 100, and then I have to connect this to this pipe, to this duct. And how can I do it? I can copy this one here because it's quite easy connecting ducts like this. And finally, I can use a flex duct to connect this option here. Okay. So now if everything goes well, the airflow should be different here. Should be 1300 as well. Okay. Well, I'm doing this class now. I have to do another return here, another return there. So each office, we need this element, which is the supply and indoor unit, and then we need the return diffuser like this. So we need six of them. One, two, three on the first floor, one, two, three on the second floor. So we will need six more outdoor units.